Hello everyone and welcome again to this Python course. Okay, so in this lecture we are going to approach here our first function from a library that is not from base Python. I really can't stress how important this lecture is if you have worked with other programming languages that are not open source or are a bit different than Python. Because here is where we are going to learn the concept of a library, also called a package or also called a module. Okay, so these three terms are intertwined between them when we refer to the concept that we are going to deal here. So these libraries are pieces of code that we can pick up, so functions that were done from other people or that are not readily accessible here in Python, and we can pick them up from outside code bases and work with them inside Python. Here we are going to detail a library that's still part of the Python environment that we install in the beginning, and that is not an external library such as others that we may deal with throughout the course, namely pandas, for example, which is a library to work with data frames that you have to install here in Python. But we'll look into this concept of more external libraries and libraries that we need to install specifically in other sections of the course. Right now we are going to use a library that's already available when you install Python, but it's not available right off the bat when you launch your notebook and your kernel. Okay, let's do this a bit slow and let's understand what this concept really means. Just have to know that libraries are really the true power of open source, because it's with this concept of libraries that we can pick up a lot of functions that were already developed by other people and put it in our code and do, for example, single lines of code to do really complicated stuff, because people already thought about it and developed those functions for us. You can also be a contributor to Python in the future by developing your own libraries and putting them on the web for people to use. And that's pretty cool. Okay, enough of talking. Let's work with the library called the math library. So this math library is a library that contains several mathematical functions that we can apply to our integers and floats. An example would be the floor function. Imagine we have here the round function that rounds our number up and down depending on where it is in terms of decimal places. If it's above 0.5, it will be rounded up. It's it below, imagining we are rounding to one decimal place. If it's below, it's going to be rounded to the nearest integer. Now, the floor function always rounds you to the lowest integer possible. If I have 3.8, applying a floor on a specific number will basically bring that number to 3. And if I have 3.2, the same to 3. If I have 2.9 and I apply the floor, I'll have a 2 because it's the lowest nearest integer that the function will round our number to. Okay, it's different from the round. So do I have this floor function already available in Python? Let's see. If I go here and write floor 2.3 or 2.4 and try to run, I'll have this mistake, name error, which will probably be the mistake that you'll deal with most of the times when you work with Python. This is super simple to understand. It just means that Python doesn't understand what this word floor really means. It's the same as if I'm calling apples 2.4. Python doesn't understand what these apples really do mean, and it's the same if I call this blah 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 2.4. It's exactly the same mistake. Name blah 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 is not defined. Of course, I can define a function called floor by myself. That's not what we want. We want to use this floor, what I've just described, this floor function, and I know that it's already available in Python somewhere. And where is it? It's in the math library. I'm going to the official Python documentation for us to see the example of the math library. Okay, so as you can see here, mathematical functions, it's even inside in the URL of the library. And these are different functions, mathematical functions, that we can call on our integers, which are super interesting. Now notice this math.ceil. Maybe, or .ceil is the inverse of floor. I'm going to the floor. There is our floor. Maybe if I can copy this math.floor and apply it, this will work. So let me test. Math.floor. Oops, same mistake. Name math is not defined. So what happened here? Well, basically, this library, although I know that I have this library available in Python, my kernel, where I'm running my notebook, can't access it because I haven't loaded it into my environment yet. And this is an extra step that we need to do for these functions that are from external libraries. Although, for example, the round is not inside the math library, it's outside. It's a function that we can use right off the bat when we start Python. The floor, it's different. It is inside the library. How can we point Python to know that this math is a library that contains the floor function? I just have to use this, import math. As soon as I run this code, I need to execute it, I'll have this function readily available. If I now run it, there you go, a return from the math.floor function. Okay, super important. We need to execute this import math when we want to run functions from these libraries. But of course, you don't need to execute it all the time. You just have to execute it once every time you are working on a new kernel. And this new kernel, it can be a notebook or a Python standalone file. But you need to run it every time you want to run functions that depend on libraries. This is what we normally call dependencies. So right now, my code depends on the math library because I have here this function that comes from that library. I don't need to run the import math again. I can run math.floor 2.5. Now it works because I've already ran this import.math. When I run the import.math, I'm telling Python, I'm giving you the direction to check where the math functions are. Now Python will remember this path until I close my notebook and close the kernel. Okay? If I close my notebook, then I'll have an issue. For instance, here I can now run all the functions that are inside the math library as I want, but if I go here, I'll leave my notebook, and if I go here and do shutdown on my notebook, right here on the working notebook, open it again, and now scroll all the way down to my math.floor, that is right here, run it again, I have again the same mistake. Name math is not defined, because when I close the connection to Python, in this case the notebook that I have opened, every time I close it and shut down the kernel, Python will forget where the math library is. And I need to give it again, so here, import math, and then I can again return to run all the functions that are from libraries again. Don't ever forget this because this is extremely important here in Python. So if you want to access certain functions, and I believe throughout your life as a Python coder, you'll need to access functions from libraries for sure. It would be extremely boring if you would be only doing code that's available on base Python, like the round functions and the pow functions and the maxes and all that, and even the string functions that we've worked with. Of course, to make Python really more powerful, you need to rely on these functions that are on libraries. Now look at the syntax. I import the math, and then I need to call the function, to point the function to the library itself. If even after I run this, import math, if I take out the reference to math.floor and run this, I'll still have a mistake, because as a standalone, floor doesn't mean anything to Python. Python needs to understand where the floor comes from, and in that way I need to point it to the math. This is the same syntax as when we call methods on specific objects, okay? When we call specific methods on specific objects, we also use the same syntax. When we call functions or methods, we can also call these methods from specific libraries, the syntax is the same. The only difference is that, of course, how we apply the arguments is a bit different, okay? But just remember that you always need to have the reference of the library attached to the function that you are running. I hope this made sense. If it doesn't, feel free to drop me a message and we'll discuss this in more detail, okay? But this is a really core concept here in Python. The concept of libraries, of why we need to point and reference these libraries before running code. And the main difference is that every time you have these functions that depend on libraries, you have to call the library somewhere in your code. There are more things about libraries that we'll detail in a section alone further down the line. For now, you just need to know that this exists and how you can access these functions, in this case using the math library. Okay, final thing, of course, let me run the math.floor to prove that this still works. And now, of course, you can also access help on these functions. You just need to pass the function itself. Think about it in this way. Every time you are referring to a function that belongs to a library, in this case, if we import it in this way, not going to go into more complex imports right now, using the name of library.function is mandatory to contrary to base Python libraries such as the round that don't need to be pointed anywhere because these functions are already available when we start the notebook. Okay, so that's the main difference. But calling help math.floor will give us the documentation for this floor function that's part of the math library. Okay, so after we've learned here a bit about libraries, let's go to the next lecture where we'll detail more functions coming from this math library. I'll see you in the next lecture.